Hi class, this is part 2 of 8B, and we have been talking about exponential decay, and this is about exponential half-life, or just half-life. And the whole scenario is the same, it's just now decaying instead of growing. So exponential decay and half-life, after a time t, an exponentially decaying quantity with a half-life time of t, half, and they just call that half-life, decreases in size by a factor of 1/2 to the t, little t, over half time. So you'll notice it's the same formula other than 1/2. 1/2 produces the decay because you have a denominator that's increasing every time instead of a numerator, and that means it's going to be the amount's going to be decreasing over time. The new value of the decaying quantity is related to its initial value at t equals 0 by, so you have the new value is equal to the initial value times 1/2 to the power of t over half time. So notice this again produces the factor, the multiplier that you multiply by the initial value. So works in the same way. All right, first example, and I'm just going to go to my notes page for the 3 examples associated with this new problem. And you have the new value is the initial value times 1/2 little t to divided by half time. Now, that's going to be our formula we'll use most often, so I wanted to make sure I pointed that out. First example, radioactive carbon-14 has a half-life of about 5,700 years. It collects in organisms only while they are alive. Once they are dead, it only decays. What fraction of the carbon-14 in an animal bone still remains 1,000 years after the animal has died? All right, so we're going to look at what we have here. We are looking at what fraction, so that's our key words right there, fraction. So that means we're just going to be using this part. This is going to be the factor part. So, so you can see it. That'll be our factor part. So we're going to have 1/2 to the power of little t. Which one of the two are little t? So 1,000 years is little t, and then 5,700 years is your half time. All right, so we'll take 1/2 to the power of 1,000 over 5,700, and we can just place that right in our calculator. Make sure it is showing you. All right, so I just put in 0.5 because it's just easier than putting in 1 divided 2. It's a lot faster. And then to the power of 1,000 divided by 5,700, and that gives us 0.885. So approximately 0.885 remains in the animal after 1,000 years of being dead. Okay, next one, example is the half-life of a drug in the bloodstream is 24 hours. So as you know, if you take like an aspirin or Tylenol or something, it breaks down in your bloodstream. So wondering, well, how much is there after 36 hours and after 84 hours if the half-life of the drug is 24 hours. So it takes 24 hours to half the amount of the drug in your bloodstream. And that is going to be our half-life. All right, t half, and then we're asked to find 2 different time, the amount in the bloodstream after 2 different time periods have passed. So we'll have 1/2 to the 36 divided by half-life. Whoops, 24 is half-life. All right, 36 over 24, and then we'll have 1/2 to the 84 over 24. And notice too that all the units are the same. Some of the problems that you'll do in your homework, you'll have to convert. They might have hours in one, like in your half-life is in hours, and then one of your time periods is in weeks or days or something, so you might have to convert a bit, but you already know how to do that. So, but just warning you, watch the units, make sure they're all the same. So we'll have, again, 0.5, and take that to the power of 36 divided by 24. But I sure miss you guys doing this for me. Oh, can't see it. So 0.35, that's how much remains in the bloodstream after 36 hours have passed. Now, you'll note that 24 hours have passed, you're going to have 1/2, so 0.5. 36 hours is a little bit more than that, so a little bit more is going to be decaying. And that sounds about right. And then we'll try 84. Now, I like to, again, arrow up here, highlight, and hit enter, and just bring it down so I don't have to keep typing stuff in. We'll just change the 36 to 84, and it's 0.088. we can just simplify or truncate to 0.09. So that's how much will be after 84 hours have passed. And you would expect it to be not much because that is several days later. All right, next example. Use the approximate half-life formula in the case described below. Discuss whether the formula is valid for the case described. Urban encroachment is causing the area of a forest to decline at the rate of 6% per year. So this is, again, where we're going to use our approximation formula for double time. For half time, because it's declining. So we're given a percent, and we'll figure out what their half-life is. Let's see, what is the half-life of the forest? So we'll have to figure that out, and then what fraction of the forest will remain in 20 years. So that's kind of important there. So we're going to take an approximation first. Remember, approximation. So that's going to be 70 over the percent, which is 6. If we do that in the calculator, I have to put it down here, 70 divide 6, we get approximately 11.67. All right, and then we want just the fraction. So again, that's just this part here, not multiplying by an initial value. So in 20 years, that's going to be our little t. And we'll take 2 to the 20 divided by this amount here, which is our half-life. All right, and that's going to be in our calculator again. I'm going to let you see what I do in here. It's 2 to the power of 70 divided by, and then I'm just going to extract it and put it there. You can just go up and highlight and hit enter, and it puts it right where you want it. And that's going to be 64, round to 64. Okay. So that's the fraction of the forest that will remain in 20 years. A little more than half, so that's great. All right, have fun with the homework. If you have any questions, don't hesitate to give me an email, and I'll try to answer anything I have. I also have done all of the problems, and I've written everything out pretty well. I'm going to post that so you can look over it as you go through the problems, and hopefully that will help a little bit as well. All right, good luck, guys.